What is meant by concave up and concave down? Concave down is generally the shape where the curvature in the picture shows is a downward curvature. And then if the curvature is an upward curvature, we refer to that as being a concave up shape. Now we're going to see what that looks like in the actual graph of a function. And the derivative that's going to be able to tell us that would be the second derivative. And we'll show what that means on the picture. So first of all, for example, we have this function, x to the fourth minus 24x squared plus 88. Let's go ahead and find the second derivative. 4x to the third minus 48x. And again, that first derivative would be giving us intervals where the function is increasing and decreasing, and also would give us possible values where we have a local maximum or minimum points. But we're going to look at the second derivative now. The second derivative for this is 12x squared minus 48. And what we're going to do is we're going to set this equal to 0. 12x squared minus 48 equal to 0. We could divide everything by a 12 and get x squared minus 4 equal to 0. And that, of course, factors into x plus 2, x minus 2. So if we do an analysis of the second derivative would be 0 at negative 2 and positive 2. And then in turn, for values less than negative 2, like negative 3 for instance, we would get negative times negative is a positive. In between negative 2 and 2, such as 0, we would get positive times negative is negative. And greater than 2, we would get values where we would get a positive times positive would give us positive. And again, we don't really care what those values are, just whether or not they are positive or negative. And what the second derivative is going to tell us about a graph is intervals where the function is in its curvature concave up and then where the second derivative is negative in that interval, the curvature, the shape of the graph, is going to be concave down, have a concave down shape. So let's see what that looks like in the graph. This is the graph of this order 4 function. Goes downward, achieves a local minimum, goes upward to achieve a local maximum, goes downward to achieve a local minimum, and then continues to increase. And again, the first derivative can show us that analysis. But what the second derivative is showing us is the curvature. Notice that in the interval from negative infinity to negative 2, that its curvature is an upward curvature. And this occurs also when x is greater than 2 on the interval from 2 to positive infinity. Notice the upward curvature of the graph. And then in between negative 2 and 2, we have a downward curvature, which would be a concave down shape, as the second derivative indicates. And remember what the second derivative is. It's actually the rate of change in the first derivative. So as we see, we're going downward to upward. In other words, the first derivative, the slope is getting greater. It's increasing. Therefore, the second derivative, which is the rate of change in the first derivative, is an increasing first derivative. And then if you notice in the interval from negative 2 to 2, we have our graph going from an upward slope to a downward slope. In other words, a decreasing slope on that interval. In other words, the rate of change in the first derivative is negative. It's going downward. It's decelerating. Therefore, that's where we have the second derivative being negative. And then, after point of 2, the function has its slope increasing, going from decreasing, curving, to increasing. Therefore, there is an increase in the first derivative. Therefore, the second derivative being positive. And lastly, we have these two critical values of negative 2 and 2, where the concave shape changes from up to down and back to up. That's where the second derivative was 0. And we refer to those 2 points as points of inflection, where the concave shape changes between concave up, concave down, or from concave down to concave up. Now, you don't necessarily have a point of inflection if the second derivative is 0. It only occurs when the concave shape actually changes at that point.